I'm super happy to be here. This is, I'm a big fan of this meetup, and so many of the speakers that have spoken here are people that I look up to. So it's very much an honor to be invited, and I'm happy to come and share a little bit about CSS. So let me share my screen. All right. Oh, I should rewind this. And I should position this somewhere that makes sense. The little Zoom UI. Okay, that seems good. Cool. So thanks so much for that introduction. The only and this is my own fault because I never know how to talk about this. I started building for the web in like 2007, 2008, doing like freelance work. I got my first job as a software developer in like 2014. So there was a gap of a few years there where it's like not on my LinkedIn, and it was more just because I was doing like smaller projects, experimentations. And for all of that time, those like 6 or 7 years, I was mostly doing HTML, CSS, and like a little bit of JavaScript. But it's true that I got my first dev job doing Ruby, which is kind of fun. All right, let me go forward. So this talk is called The Hidden Fundamentals of CSS, or The Secret. It's one of these things where I kept forgetting what I had called my own talk. I think it's The Secret Fundamentals of CSS, or The Secret Mechanics of CSS. Let me actually do this locally because it's occurring to me that I might be using an older version of my talk. I don't want to do that. Oh no. Okay, one moment. I'm going to restart my server and make sure I'm in the right branch. It's funny because I spent a good amount of time this morning going through this, but then I switched to do a bit of dev work. And in that period, things can go off the rails. Okay. So I had a bit of an interesting realization recently, which is that CSS is kind of a magical language. And I'm using the word magical in a very specific sense. I'm using it in the same sense as Rails magic. So as I mentioned, right, I started my career doing Ruby. And the interesting thing about Rails, it's kind of known, maybe even notorious for the Rails magic, which is this idea that you write a little bit of code and all this stuff happens that most developers aren't aware of. And it's super great because it means that you can write this little bit of code and a bunch of stuff happens and you can build an application really quickly. But the downside to this is that when things go wrong, right, when you go off the rails, when you get off the little happy beaten path, it's really tricky to debug because you don't understand all that magic that's happening. And just like a quick example, right? I've written like 10 characters of CSS, and it changes so much about how these three elements and even its parent element is rendered, right? It changes the position of them. Like the obvious thing is it puts them side by side, but it even changes how CSS properties will work on these elements in ways that I don't think most developers have fully internalized. So that's kind of the theme of this talk, right? That's what I want to talk about. It's like a really heavily abstracted language. And if we can get comfortable with that, the kind of behind the scenes stuff, it makes the language feel so much smoother. Like I think we've all had that experience where we have this like go-to snippet that we've used over and over again. And then one day, randomly, it doesn't work, right? Or it does something different than you expect. And this can make the language feel really inconsistent and unpredictable. Like, what the heck, CSS? I know this snippet. This isn't some new experimental thing. But what's happening is there's some small detail in the implementation. There's some property on some element that might be 15 layers up in the tree that's changing how this is working. And it's really frustrating. And the only way to get around that frustration is to understand what CSS is doing. So let's get into it. The first thing I want to talk about is layout modes. And this was kind of a fundamental shift that I realized, that CSS is actually kind of a collection of mini languages, or at least mini algorithms. Like we have flow layout, which was the kind of, actually make this a bit bigger. It's kind of like the default, the original language of the web. There's positioned layout, which is when you set the position property. There's flexible box layout, commonly called flexbox. And then there's CSS grid, and there's like a bunch of other ones like table layout and float layout, things that are still actually kind of useful, but we don't talk about all that often. And today I want to focus on these first three. I want to share some of the things that I've learned that have really helped me build an understanding for how these layout algorithms work. And we'll start with flow layout. So the way that I think about flow layout is it was the first one, right? It was the one that came out with CSS. It applies to almost every element by default, except for tables, I think. And it's inspired by real world documents, as well as like word processing software, because you have to remember, right? When the internet was like a new thing, when CSS landed, which wasn't exactly at the same time, but in the earlier days, we kind of thought of the internet as this big interlinked network of documents, like everything was Wikipedia. And that's the lens that the language designers use when building CSS. So we have this kind of idea of we have these blocks, headings, paragraphs, and they're stacked vertically. And within those blocks, we have inline positioned things, whether they're words or characters. And this is kind of the cardinality, right? The directionality of the web. You have vertical blocks stacked one on top of the other, and the blocks are made up of little elements that are stacked left to right and line wrap. Of course, I should caveat, right? We're talking, in this talk, I'm talking about English, which is horizontally written left to right languages. There are plenty of languages that are written right to left, and then there are even some languages that are written vertically. And so in that case, right, a lot of Asian languages are like this, although from what I understand, even if the language is traditionally written away on the web, we typically see horizontal text, but it doesn't have to be. You could have the characters arranged vertically, which would mean that inline is your vertical direction, and then the blocks go horizontally in one of the two directions. So yeah, that's a caveat. I do, I imagine if you're joining this talk, if you've been with the CSS Café meetup for a while, you're not new to CSS, and some of this might seem a little bit obvious, but I do want to just like take a moment and dig into how this works and talk about like the frame that I use in terms of understanding things. I'm really trying to build out, like put into words what you may have kind of a vague understanding about. So if I have this heading over here, oh, I hear crunching. I think someone might be Oh, actually, I'm gonna grab some water. Take advantage of the opportunity. All right. So I have here two block level elements, and the second block has some stuff inside, some inline stuff. And I think what's interesting about block level elements is that they're very greedy. Like they will automatically grow to fill the space, and they're not neighborly. Like they don't want anyone else sitting kind of in their space. And I can kind of prove this if I give it, let me actually move this. If I say we have a paragraph and an H1, and both of them I'm going to give a width of like 100 pixels. So obviously they now constrain really kind of tightly together. And even though there is like theoretically space for both of them to sit side by side, they don't do it, right? Like they still kind of maintain their own block on the page. Block level elements, you can think of them almost like as layout elements, like they're meant to control parts of the page. I don't know why, by the way, it's interesting. Chrome will use the margin color to like indicate that this space is reserved, even though it's not margin. Firefox DevTools don't do that. I don't really understand why. But I do think it's worth talking about block level elements as these elements that will like very greedily take up the space by default. By the way, one thing that was not clear to me at all for a long time, there is a difference. Like I used to think that block level elements would just be set to width 100%, right? And if we give it some border so we can see what it's actually doing without the dev tools, that does seem to be what's happening. But that's actually not the default value of width. The default value of width is auto. And it isn't immediately clear what the difference is between these two values, but it has to do with whether or not there is other stuff in the way. So like if, for example, I say margin left 32 pixels, you'll notice now that like the element is constraining and expanding. It's doing what it has to in order to occupy the space. Whereas if I had set width to be 100%, it's going to overflow because it really is like I am taking up the full space that is made available to me. So that's block level elements. I want to talk a little bit about inline elements too. And after I have some more water. So if I have on this strong tag, I have margin top, and let's just say 32 pixels. Nothing happens, right? It doesn't have any sort of effect. And that's because I think of inline elements as like very chilled out, like go with the flow kinds of elements. They don't want to make a fuss, right? Like they don't want to push elements around. They're happy to do it in the inline direction because that's kind of, the way that they're meant to go is in the inline direction, but they really don't want to fuss with things in the block direction. And this leads to some pretty interesting effects. Like I can say padding top 32 pixels, and it doesn't look like it does anything, but if I give it a background color, it has this kind of weird thing where the padding is there, but it isn't going to disrupt any other elements on the page. There's nothing I can do to this inline element that will move its block level siblings, right? Like that will move this heading over here, or even its own parent paragraph. Like inline elements really don't want to fuss with things in the block direction. So with those two kind of worldviews in mind, what the heck is the deal with inline block? And this is one of those things that for many, many years, I would read the definition and it would make sort of theoretical sense to me, but I would have no idea. I didn't really get it. And so here's how it works. Inline elements are put on the page as if they were inline elements, right? They are positioned in the same way that any other inline element is when the browser is going through and rendering the elements, but it has a vote when it comes to layout. So like block level elements, you can actually use some of those properties like margin or height, for example. So, whoop, that's the wrong little shortcut. Here's like kind of a similar setup. I have a span around this child, except now I've given it display inline block. And so now if I say padding top, it actually does, like you'll notice its siblings move around, and I can say margin bottom. And then if I had like a paragraph here, it actually can shift things around, which is pretty cool, right? The fact that I have this inline element that has this new bit of ability, but it like opens the question, why would you ever want to use inline when inline block is available, right? It seems to offer the best of both worlds. And the answer is something that, as far as I know, is totally unique in the CSS language, right? Inline elements have this very special ability that you can't get in Grid, you can't get in Flexbox, and that's the ability to line wrap. So you'll notice here I have the exact same setup, except now I have more text inside this inline block. And as a result, I have these kind of huge spaces, both over here and over here, because inline block elements, like block elements, are going to form a rectangle. Like you can always draw a rectangle around any block level elements, and the same thing is true for inline block. If I don't have this, then it's no longer a rectangle, right? It kind of just blends right in naturally to its parent inline context, which is really kind of cool and something that I think, you know, for all the talk about Flexbox and Grid, this is something you can only do in flow layout with inline elements. Okay, so all of this, I think, kind of builds to this interesting dynamic in flow layout that I didn't understand for like a decade of writing CSS. And that's the idea. And we're going to look at this in terms of like a very common problem that has a very common solution, but the solution isn't one that I ever really understood. So to kind of give the setup here, we have in our HTML this div ID root, which covers the whole website. So it has our header, our main content, and our footer. And like most websites, I want this footer to be at the bottom, right? It should be over here, but it's not. And on the root, I've set height to be 100%, and I've made it a flex column, and I've set that the main should grow to fill the available space. This height, though, it isn't actually doing anything. And one sec, more water. Yeah, like it's weird because width doesn't have the same problem, right? Like I can go and say width 50%, and we'll give this a border as well. That does what you expect, right? It reduces the width of the parent element that wraps over everything by 50% of the available space. Whereas height, like I can set it to be any percentage I want, and it has no effect at all. And to understand why this is and what's going on, we have to talk about how width and height are calculated in flow layout by default. So we'll pick this header as an example, right? The peach puff background element that contains the heading of the website. And we say, okay, how is the width of this element calculated, right? Well, as we talked about, block level elements are greedy, so they're going to grow to fill the available horizontal space. And so in order to know how wide this header is, we have to know how much space is made available to it by its parent. And so this div ID root, we can go look at the styles. That's why, like when I set width, and I'll use a number value, right? 400 pixels. Well, then when we're figuring out the header, we say, okay, well, the parent is 400 pixels. That means that it makes 396 pixels of space available because we have to subtract the border, which might be only 1 pixel. Either way, right? It's the amount of space made available by the parent, not including its border. Same thing if we had like, I gave it a bunch of padding, we'd have the same problem now where like, this is 100% of the parent space minus the padding and minus the border. And so if we want to know how wide an element is, we have to look to its parent, and then its parent will look to its parent, the body tag, which looks to its parent, the HTML tag, which by default is the full width of the document. But what about height, right? Like how tall is this header? Well, to figure that out, we have to add up the height of its children, right? So let me get rid of this. And we'll go back to here. In fact, let me get rid of this too. So like I can measure it, right? This thing is approximately, I don't know, 72 pixels, 74 pixels. And that's because this heading is that space. If I was to add another paragraph in here, well, now it would be like the height of that heading plus the height of this paragraph, plus like any padding or margin between them. And so in order to understand how tall the header is, we have to look down the tree to figure out how tall its children are. So there's this fundamental difference where for width, you look up the tree, for height, you look down the tree. And so what does it mean to set height 100% on this element? Because what's actually happening here is root is saying, okay, I want my height to be 100% of my parent element. The parent element is the body tag, and the body tag has these styles and nothing else. And so the body tag is saying, well, wait a minute, why are you asking me? Like, I'm waiting for you to figure out how tall you are so that I can grow and shrink. You know, I want to be as small as I can to contain this content. And again, this all goes back to documents, right? Like this is how documents work. Documents have a fixed width, right? If you can't print off the side of a page, but they have unlimited height because you can print multiple pages, right? You can have a 75-page document. Each one of those pages has the exact same width, or rather every document collection in the world has that, well, not in the world, but you know, like there is a defined width that the paper is, and you can exceed it in the height direction because you can print more pages. And that's kind of the model that flow layout takes. And so we have this kind of recursive condition where root is saying, I want to be 100% of your height, and body is saying, I don't know what that means because you need to tell me how tall you are for me to obey that. And this recursive condition just kind of explodes and nothing happens. We can fix it if we give body a fixed height. So if I was to say height 1,000 pixels, that's 100 pixels. Let me do 1,000. That's not how you spell pixel. Now it works, right? Because now when the child says height 100%, body, we've opted out of the default behavior of it shrinking to contain its children. And now it's just going to be whatever this pixel value is. So this works. So the fix to this problem that I suspect many people have seen before is you say HTML body and you say height 100%. And now it does what you expect with the footer at the bottom. The reason this works is that you're following the tree all the way up, right? So root says I'm 100% of your height. Body says I'm 100% of my parent's height, the HTML tag. The HTML element doesn't have a parent. And so when you set a percentage-based height on HTML, it uses the viewport, right? So it's now going to say, I'm just going to be whatever height the viewport is. And because that's now a known value, it doesn't depend on its children, that value can be used by all of its children. And so we eventually make it to the point where this actually does something. One small caveat, normally what I'll do is I'll use min height. And that's just like a way to make sure that if I have more content that can comfortably fit on the page, it's allowed to add a scroll bar without anything overflowing. But yeah, that's one of these things that I would copy paste this little snippet to make it work for years and years. And once I finally realized what was happening, it was like just such a nice moment of understanding. Now, I know that many of you will probably have been like screaming at the monitor for the past 5 minutes. Like there's a unit for this. Like maybe I'm making my life unnecessarily complicated, right? 100 VH, right? You can see in like 2 lines or 2 characters, 100 VH fixed. But not really, right? There is a problem with this and it has to do with mobile. So let me zoom out. 100 VH on mobile refers to the total height of the available space once the phone goes into this like minimal browser UI mode where and this is Safari. I think something similar happens on Android. Not entirely sure, but I know that I've heard of similar issues on Android with the VH unit. The top line gets smaller. The bottom toolbar with the back button in that just disappears entirely. And this is the height that 100 VH resolves to. And so what that means is when the page loads, when you have all this extra stuff, you have a scroll bar. Like 100 VH is not 100% of the available space. It's taller than that, which means that if you want something to appear at the bottom of the viewport, it's actually going to be hidden by default because it's going to be below those buttons. There is a solution to this coming in CSS. There's going to be new viewport units that let you specify either the shorter of these 2 values, the taller of these 2 values, or a variable one, like one that changes. But as far as I know, that isn't in any browsers yet. So until it is, this trick with all the percentages is how we have to go about solving that. Okay, that's my interesting fact on flow layout. Let's talk about positioned layout. So the fundamental idea, as I see it, with positioned layout is that instead of following the typical rules of elements being thought of in block or inline contexts and being nested within each other, they're anchored to something else. And the something else is going to depend based on the value of the position property. So one of the more common examples, absolute positioning. Right here, I have this teenager. The teenager has been told to go to their room by their parent. But like the rebellious teenager that they are, they have not listened and they've gone up to hang out at the address bar. That's my little, go to the bar. That's my joke for the talk. The way that this is happening, the reason this is happening is that this element is not being contained by its parent. And this opens up one of these little mechanisms that I suspect many people have certainly run into and have an idea about. It's this idea of containing blocks, right? So every element in every layout mode, I think, has a containing block, and the containing block is the rectangle that is the used in the layout calculations for like where it's housed or what it's constrained by. Different layout algorithms will use the containing block in different ways, but there's always a containing block. And in flow layout, like if I get rid of this, it's usually its parent, right? So this teenager is being contained by its direct parent, and the containing block is the rectangle inside the border, inside the padding. It's the content space. But when I set position absolute, it breaks free of that. And the way that works is that absolutely positioned elements will be contained. They'll be anchored to their nearest positioned ancestor, which is to say, it kind of goes up the tree looking for something else that sets the position property. So if room was to set position relative, well, now it does what you expect, because now the containing block is a box the size and shape of this element inside its 5 pixels of border. If it makes it all the way to the top of the tree, right? So if we get rid of this, it looks at room. Room doesn't set the position property. So it looks at its parent, the body tag. Body doesn't set it. Body looks at HTML. HTML doesn't set it. Then it uses what's called the initial containing block, which is a box the size and shape of the viewport, which is why this pink circle is sitting in the top left corner, because I've anchored it to that containing block in the top left corner's position. I can say like bottom left just to show that it is in fact a box the size of the viewport. Yeah, that's just one of these interesting things. I also want to talk briefly about fixed position, because I think a lot of people think of fixed position as like it's absolute, but you've ignored scrolling, which is mostly right. The way that I like to think about it, right? If the viewport is your view of a landscape, if you're on a train and the train is going by and you have a window, right? That's your view of what's happening. Then fixed position is like a bug that lands on the window. And so like the background is flying by because you're on a train. The bug is anchored to the viewport itself, right? So it's not that it's ignoring the fact that the train is moving. It's that it's stuck. It's anchored to the viewport. So that's what fixed position is. I'm saying no matter what happens on the page, right? I am using the viewport itself as my containing block. So as I scroll, the viewport doesn't change, right? The window on your train doesn't change. It's just what's happening, what that viewport is showing you that changes. Okay, let's talk about everybody's favorite property, ZIndex. So here's the canonical or the most conventional or typical problem with ZIndex. I have this h1, hello world. I have this image of a cat. They're siblings. Image has been given a ZIndex of 1. H1 has been given a ZIndex of 10. The heading is behind the image. And the way that I would have explained this for most of my dev career is that the ZIndex has an implicit dependency on the position property, right? So I need to set it to something like position relative, and I probably should set it over here too, just in good form, right? That's how I would have explained it, that there's this dependency between the ZIndex property and the position property. It needs to be relative, or it could be absolute, right? It has to be set to a different value. And this is not wrong, right? It is true that that's how it works, but it's not really the most accurate way of framing the problem. The way that I would describe it now is that different layout modes will implement different CSS properties. Flow layout, as the layout mode concerned with magazine and document editing, right? Like, or word processing layouts. If you ever use Microsoft Word, things don't overlap in Microsoft Word, right? That you can drag the image around and it totally breaks your layout, but it's never going to go behind text. That's just not something that this layout mode has in mind. So flow layout does not implement this property. Positioned layout, where you're talking about like moving things around in kind of arbitrary anchor points, well, that actually is a concern that it has. So the positioned layout algorithm implements the ZIndex property to have certain functions. And you may be thinking that that's like, a distinction without a difference, like two ways of saying the same things. What's the difference? But there actually is a difference, which is I can remove this and I can remove this. It goes back to not working. But then on the parent main, I can say, oh, that's not the right bracket. I can say display flex direction column, and my ZIndex works again, which is weird, right? I haven't set position. The reason this works is that the flexbox layout algorithm also implements the ZIndex property for its children. If something is being rendered in a flex formatting context, ZIndex is implemented once again, which is something that when I first discovered it, I was teaching at a local boot camp, and a student came up and asked me like, hey, why is this working? And I legitimately like spent like half an hour with them, like trying to figure out how on earth this was possible. And it was just that my mental model was wrong. And that's like the funny thing about CSS, that you can have a mental model that is 95% correct. And so you'll go through your career with this slight gap that you just never notice until one day, the fact that it doesn't line up causes this problem, and then there goes your afternoon. But yeah, ZIndex is a property. Every layout mode can implement any property it wants, however it wants. And in this case, the Flexbox layout algorithm has implemented it the same way that positioned layout does. One more thing on position layout, and this is another one of these hidden mechanisms. This is another problem that caught me off guard that made me waste a whole bunch of time trying to figure it out. I have this tooltip. The tooltip is behind the header. And let me actually, it's maybe not the most obvious. Maybe if I make it like minus 20 pixels. Yeah, like you can definitely see, right? This tooltip is behind the header. And this is weird because tooltip has this very, very large ZIndex. The header that it's behind has a very, very low ZIndex. It's not a layout mode issue, right? They're both setting the position property. So what the heck is going on here? How can it be that this element with this very large ZIndex is behind this one with a very low ZIndex? Well, it has to do with stacking contexts, which is another one of these like implicit concepts that you can spend a whole career never learning that word, and maybe even not even running into this problem until one day it derails your weekend. And what's happening here is that ZIndex values are not compared globally, they're compared within their given context. And so whenever you essentially apply ZIndex in a way that works, well, that's not entirely true, but it's close enough for this purpose. It will then create a context where any of its children are bound by that decision. So let me explain. We have this header, it sets ZIndex 2. I have this main element, it sets ZIndex 1. And because we've now created two stacking contexts, anything inside these elements becomes effectively flattened, and they're just coming along for the ride. So we've said that the main element, right? The main element is all of this stuff over here, should be behind the header element. And it doesn't matter what any child element does within that context, right? Tooltip can control whether it's below or above this little paragraph over here, but it can't control whether it's below or above something in a totally different context, right? It's not making that comparison. It's been flattened so that everything inside this main has an effective ZIndex of 1. Water break, 1 second. Another way to look at this, an analogy that the JavaScript developers among us should appreciate. You can think of it like version numbers. So every time you apply a ZIndex, it effectively adds a dot to your version. So we can say that this header over here has an effective version of 2, right? Because it's ZIndex 2, and that's the very first number that we've come across. The main element can then have a ZIndex, or like we'll call it a version number of 1. But then what about this tooltip, right? What is this tooltip? Well, it's not 999,999 because it is like the minor version of this major version over here. So it's actually 1.999999. And as we've no doubt experienced, it doesn't matter like how many nines I add to this number, it will never be a larger number than 2.0, right? Like I'm kind of implicitly adding to 0. But this is the minor version. So the minor version is never, no matter how much you crank it up, it's never going to surpass a major version. And similarly, like if this tooltip had an element, let's say it had a button, and that button had a ZIndex of 5, like just for argument's sake, it would be 1.all_the_9s.5, right? And it can keep going. It doesn't have to be just like 3 of them. Every time you effectively apply a ZIndex, you wind up creating a context that kind of flattens all of its children, so that you can't have the situation where this tooltip is going to be above this header when its parent is below. And when you think about it, it would be chaotic if you could do that, because then you'd have all kinds of like weird interwoven layers, and it wouldn't be very pleasant. Okay, let's talk about one more layout mode. Let's talk about Flexbox. So, It's another layout mode. The main thing with Flexbox is it concerns itself with how we distribute items along a single axis, and then like secondarily, how they're aligned in a cross axis. And we can have it be a row or a column. Like all layout modes, though, Flexbox can choose how to implement all CSS properties. In the same way that Flexbox chose to implement ZIndex, it can override or define properties however it wants. And I think this probably makes an intuitive kind of sense in terms of like, justify content. That doesn't do anything. Or flex grow. Like that's pretty obviously a Flexbox property, but it applies to all properties, right? So here I have an example of that. I have this div class item. Item has a single, well, it has some cosmetic properties just so we can actually see it. But in terms of layout, it has one property, which is width 2000 pixels. When that element is rendered in a flow context, it is 2000 pixels wide, right? It is the width that we've said it should be. We've asked for it, we've gotten it. When I take that same element though, like, and you'll notice it's exactly the same element, and I put it inside a parent with display flex, now it's not 2000 pixels anymore. Now it kind of grows and shrinks to fit its container. And this is because the Flexbox algorithm redefines the width property so that it defines the hypothetical size. That's actually the term used in the specification, which I kind of love. The hypothetical size of an element, the size that it would be in an idyllic world where there were no constraints acting on it, right? In this case, it can't do that because there's this parent that isn't 2000 pixels wide, and Flexbox will try to make items flex so that they fit in the given amount of space. I also want to talk a little bit about flex grow and kind of the way that most of us use Flexbox, because there's this subtle thing that, at least for myself, I should only speak for myself, but for myself, I didn't realize for the longest time. So if my goal, I have these two elements, and I want them each to take up two equally sized columns, right? So both of them will take up 50% of the available space, and that'll be true regardless of the viewport size. I think that many of us, if we've worked with Flexbox before, we've internalized that we do this by setting flex 1. And sure enough, when I do that, I have two columns that are of equal size. I mean, if I shrink it so far, then I think something funky. Yeah, it can't shrink below its minimum size. But as long as we're not below that minimum size, it does kind of try to honor this 50% each rule. But what is this shorthand, right? What does this actually mean? For a long time, I thought this was a shorthand for flex grow 1. But when I change it, we can see that that's actually not true. Like if you keep your eye kind of over here, and I'll kind of toggle this on and off, right? If I remove it and then add it and then remove it, it's very similar, but it's slightly different. And that difference is exaggerated if I make one of these children longer. Right now, obviously this one is much larger, but if I set flex 1, then it line wraps and we're left with two equal sized columns. The thing that's going on here, actually, before I explain it, I want to show how this gets even weirder. Let me set flex grow to 1, and now let me set width to 0 pixels. And that seems to have the same effect, right? It also creates two equally sized columns. It is slightly different. If I go really small, then we see that they are allowed to overflow. But generally speaking, it does kind of do the same thing. Why on earth would setting width 0 pixels cause these two columns to be equal sized? Well, we have to talk about what each of these properties is doing. So let's start by just looking at it without either of them. We have these two children, and then we have some amount of extra space. Right here, it looks like it's about 170 pixels of extra space. So when I set flex grow 1, it takes that 170 pixels of extra space and it divides it in two, and it gives each of them that extra space. So that like we have, like with the padding considered, like 80 something pixels in each one that has been added, and that extra space has been shared. When I set width to 0 pixels, something kind of interesting happens. It has now shrunk them to be as small as they can be. It's not quite 0 because there's padding and borders and things, but it effectively ignores the content so that it can shrink to be really, really small. And now when we put those two ideas together, it starts to make a little bit of sense, which is we've set this hypothetical size to 0 pixels, which means everything else, all of this space is now extra space. So it's going to take this 460 pixels of space when I add the flex grow. It's going to take, let me retype it, flex grow 1. It takes 230 pixels and it gives it to this first child, which used to be this wide. So it's this wide plus 230. And it does the exact same thing to this one, which, because they were both shrunk, are the same size. Now, this only holds true if both children have the same padding and border, which is one of those little facts that can really bite you if you don't expect it to. But as long as the children have, and this is true, by the way, for the same shorthand, right? If I set flex 1 and I give like aside a bunch of padding, hold on, let me actually do this properly. If I remember how to type my CSS. If I say aside padding 128 pixels, well, now they're not doing the equal column thing, which is another thing that can kind of ruin your day. But as long as they have the same padding, you'll get 2 equally sized columns. In terms of what this shorthand actually does, well, it is a shorthand for flex grow 1. It doesn't change flex shrink. That stays at 0. I think 0 is the default value, but it sets flex basis to be 0. And I always forget if it's actually 0 or 0%. Doesn't really matter. Flex basis is very, very similar in its behavior to width in a flex row and height in a flex column. This is one of those things that I always thought there was some like really significant difference between them. There isn't. They do the same thing. The differences are that flex basis has some effect in terms of not letting it shrink below its minimum size, right? So if I change this to width 0, then we see that they're allowed to overflow. So that is a difference. And there's also, I think, in terms of prioritization, I think flex basis will win over width. So if I set width to some value, I think it's ignored. I might have that backwards. And actually, now that I think that it does still have some effect. But the point is that like they essentially serve the same function of controlling the hypothetical size of an element in a flex container. And the reason that we have it is so that we can easily flip, I can make this a flex column, direction column, and I don't have to change width to height because now flex basis controls the height, not the width. I think that's everything I had to say about that. So let's keep going. Oh yeah, I have like a couple of summaries of this because I think it's important enough that it's worth reviewing. Flex basis is like width in a flex row or height in a column. Both of these properties, flex basis and width, are really more of a suggestion in Flexbox, right? We're setting the hypothetical size. We're requesting that this is the size. What we actually get in the layout depends on the grow, the shrink, the size of the container, the size of the children at the content, all of these things. Flex 1 is a shorthand that, in addition to changing flex grow the way I always thought it did, also sets flex basis to 0. This is a really nice graphic. I think it's from the W3C. It's from some official source, if not the W3C, that kind of explains this. The default value of flex basis is auto. And when flex basis is auto, it distributes the extra space. So it kind of takes whatever space is left over and chops it up based on the flex grow ratio. So in this case, we have 4 total, right? 2, 3, 4. So it's going to say, okay, you get 1 unit of each, or I guess, if we're talking on each side, there's 8 little units. But the point is that like this whole element gets 1/4 of the available extra space. When we set flex basis to 0, it divvies up all of the space so that we really just create equal sized columns, assuming the padding and border is the same. One more thing I want to talk about. I think this is the last little, I appreciate your patience, by the way. I know that this talk is not lightning quick. The difference between justify content and align items is something that continues to stymie people. And a question I've gotten a few times on Twitter is, why is it justify content and align items? Why aren't they both content or both items, or justify items and align content, right? What is the difference? Why do we have this overly complicated system? The first thing to understand is that justify refers to the primary axis and align refers to the cross axis. So I've kind of labeled them here. We have a flex row. And the difference has to, let me actually center both of these so that we can get them both kind of in the middle. Notice that the primary axis skewers all of the items in the row, like a souvlaki stick, right? Like you get all of them. There's a single line that passes through all of them. The cross axis will only ever pass through one, like unless you cheat and you draw it diagonally. If it's a perpendicular line, it's only ever going to pass through one. I am omitting flex wrap. That does kind of change this, but actually the rules I'm about to talk about still apply with flex wrap. The idea with content, so justify content, is that you're talking about the items as a group, right? You're aligning the content of the parent, which can include one or more items. And I'm saying the content should move to the middle. The content should be equally spaced so that we kind of add space between them, but keep them on either end. In both of these cases, we're talking about the items as a group, whereas with items, we're talking about the items individually. In fact, align items is just a shortcut that sets align self on each of the children. And if you think about it, it kind of makes sense, right? Like, why is there no justify self? Well, what would it mean if I took this hello, the first element, and I set justify self to flex end? Like, would it overlap with world, right? It can't move without affecting its siblings because they're all like bits of chicken on this souvlaki stick. You can't move one without affecting the others. Whereas with alignment, or sorry, with items, when we're talking about the cross axis, you actually can move individual items because like I can move this one up and down. It doesn't make any difference to the other ones. So that's what I think an important distinction is, that the reason that we have this, if flex wrap was enabled, and I'm sorry, I don't have a demo for this, but like if I did have them enabled, then content would move both of the rows together and items would move the items within that row, which is how it all kind of gets tied together, and why in CSS Grid you actually do have all of these things, because in CSS Grid you're talking about the grid structure versus the items inside their given cell. So it really is just a limitation of like, it's not even a technical limitation. It's just like, what would it mean to move this item so that it was aligned to the right? I think sometimes what we want to happen is like, maybe I want this item to be on the left and the other 3 items to be stacked kind of over here, right? Like just force them all to the side. We actually do have a way to do that in Flexbox, but it doesn't use these alignment properties. Instead, I'm going to grab the first hello and I'm going to set margin right auto, and check that out, right? It does. I'm going to get it in the way. It essentially what margin auto does in a Flexbox context, again, right? Flexbox defines the margin property, however it's convenient for it, is it works kind of like Flex Grow in terms of if I remove this and if I set justify content to Flex Start, I have like, I don't know, 525 pixels of extra space. Margin right auto will greedily gobble up all that extra space and use it for the right margin, right? So now this margin is equal to that same 525 pixels. Like Flex Grow would eat that extra space, margin auto can eat that extra space. And this is something that is similar to how margin auto works in other layout modes, but is really specific to Flexbox. All right. So there's so much to CSS that I would love to talk about. I could do this all day. I really could. Because there's all kind, we didn't even talk about overflow, which is this whole other can of worms, and so many different things. I do have a CSS course. My CSS course is essentially the things that I wish I had known 5 years ago when I really started trying to teach myself the mechanics of the CSS language. It's a multimodality course. There's a lot of the lessons look like they would in my blog post, but there's also video. There's 170 videos. There's, in fact, all the little interactive things in this presentation. The little secret here is that this is actually running this presentation in my course platform. So I'm able to use the same components. And then there's like mini games, which I think are particularly cool. In fact, if you'll indulge me, I'd like to show you this one in the actual DOM because it's kind of neat. So I go to Will It Collapse? And so this is a game that kind of helps you understand how margin collapse works. And the idea is you have this box, you're shown some CSS, and you drag the box around, right? So if it has margin top 20 pixels, well, then you probably want it to be 20 pixels from the top. And the idea is you move the boxes. If you get it wrong, you can kind of toggle to show what the right answer is. And as you're going through, they get more and more complicated because, you know, real CSS is complicated. So you get situations where like, aha, now this parent box has padding top 20 pixels. This item has margin top 40 pixels. Does that mean it's going to be 40 pixels or 60 pixels? Do we add them? And it turns out you do. Or no, you don't. Oh, I see what I did wrong. Okay, I'm not going to try to debug that now because I'm going to embarrass myself. But essentially, that's what you kind of go through and you choose based on the CSS what these individual elements should do. And this is the kind of, it took me a very long time to build my own course platform, but specifically because I wanted to embed little experiences like this is why I did it that way. So you can learn more about the course at css4js.dev. It's a little play on CSS in JS, if you've heard of that little terminology. That'll take you to the landing page that tells you a lot more about the course itself. I created a little special coupon code for y'all. It's CSS Café, all one word, no accent. And it'll take 10% off the price of the ultimate package, which is the kind of the full course, because I have other packages you can buy depending on the content that's included. If you'd like to take 10% off the course of that the full package, you can use the code CSS Café. I think I set it to have 10 or 20 redemption limits, which should be plenty, but just know that there is like a finite quality of them. Also Twitter, you may have noticed I have my handle kind of up here in the corner, Josh W. Comeau. So I share a lot of like quick tips and CSS stuff on Twitter. So you can also check that out as well. That's all I have. Thanks so much.